Let's determine whether the sequence a sub n equals cosine squared of n over 2 to the n converges or diverges. First, let's write out our sequence. To analyze the sequence, let's make a key observation about cosine squared. For any real number n, cosine squared of n is always between 0 and 1. This is because cosine is between -1 and 1, and when we square it, we get a value between 0 and 1. Now, let's look at the denominator. 2 to the n grows exponentially as n increases. We can see this by plotting some values. 2 to the first is 2, 2 squared is 4, 2 cubed is 8, and so on. Now, let's put these observations together. Since cosine squared is between 0 and 1, and we're dividing by 2 to the n, we can use the squeeze theorem. Our sequence is bounded above by 1 over 2 to the n, and bounded below by 0. We know that 1 over 2 to the n converges to 0 as n approaches infinity by the squeeze theorem. Since our sequence is squeezed between 0 and a sequence that converges to 0, our sequence must also converge to 0. Let's visualize some terms of our sequence to confirm our conclusion. As we can see, the terms get closer and closer to 0 as n increases. In summary, we proved that the sequence cosine squared of n over 2 to the n converges to 0 using the squeeze theorem and our knowledge of the bounds of cosine squared and the behavior of exponential growth.